So this is the setup we're using to demonstrate the CFM matching technique. We have a box that's simulating a server rack, and we have a red heater and a yellow fan here at the bottom that simulates servers blowing hot air into the server rack, which are the heat loads. And then we have the CFM sensor itself here on the front. And on the top we have a electrically commutated fan, and that's the exhaust fan that's going to be exhausting the hot air that's being blown in by the servers. And we have a laptop that is just used for plotting the speed of the fan. It shows speed as a function of 100%. And the little green flap there is going to show pressure inside the cabinet, whether the pressure is positive or negative. So, for example, if I turn the servers on, the airflow simulating the servers, that'll pressurize the cabinet, and you'll see that the green flap is showing that the cabinet's pressurized and air is being blown out of the cabinet. So let me get this all running here. Just set this up. So I'll plug in the heaters for the server. It's about 1,000 watts of heat, and the fan generates anywhere from 100 CFM to maybe 500 CFM, again simulating the servers. Plug in the power to the CFM sensor, and that'll activate the fan, the exhaust fan. And it's now, the CFM sensor is now detecting the airflow through an orifice. The CFM sensor has temperature sensors both outside and another one inside the server rack, and there's an orifice that it uses to sense the air, either the pressurized air being blown, the hot pressurized air being blown through the orifice to the outside, or the cold outside ambient air being sucked in through that orifice, and that's how it knows what to do with the exhaust fan. So as it modulates that fan, you can see the flap start to go to the neutral position, which would be mostly straight down, and you can see that the speed of the fan is decreasing as it's trying to find that CFM balance point, where the exhaust fan is matching the CFM of the servers. So we'll let that go until it's pretty much balanced. Which right there is actually pretty close. So what I'll do now is come over here and turn the fan on high, simulating that the servers are speeding up their fans. You can see that the pressure inside the cabinet is causing the flap to blow out. And you can also see the corresponding increase in the fan speed. And again, the laptop is just plotting the speed of the fan. The laptop isn't controlling the speed of the fan. The speed of the fan is being controlled by the CFM sensor. So again, it'll find the point where the exhaust fan matches the CFM of the server's fans. And that's pretty close, probably. You are seeing some fluttering of the little green flap there, but there is a lot of turbulence. It's more a question of the net pressure. Is the net pressure neutral? And that's probably pretty close. You can see that the plot is pretty much leveled off. And then again, if I come over here and just reduce the fan speed on the servers again, turn it down to low, you'll see that right away the pressure is negative in the cabinet, causing cool air to be sucked in. You see the flap being sucked in. And now you see the exhaust fan being modulated down, as again the CFM sensor is trying to find that matching point where the pressure is zero, is equalized. Yeah, it's getting pretty close there. And it's pretty much equalized there. So that's pretty much it. That's a quick demonstration of the CFM matching technique. And we've actually tested this on real server racks as well, with fans on top of the server racks and fake heat loads, not real servers, but it performs in the same manner. So that's a demonstration of the CFM matching technology.